this is going to be very informal. I didn't create any slides. I want to talk informally. And basically what I want to do is sort of cover three things. First, I want to tell you that when it comes to climate change policy, what should we do? All that really matters is the possibility of a catastrophic climate outcome. In other words, if you think about middle of the road, or the 90% confidence interval, or the most likely, or all that kind of stuff, it doesn't really, it's hard to justify much in the way of a stringent abatement, greenhouse gas abatement policy. It's really the possibility of a catastrophic outcome that matters. I want to talk about that. The second thing I want to talk about is tell you a little bit about what we know and what we don't know about climate and climate change. What do we understand about the possibilities for climate change and how greenhouse gas emissions can lead to climate change, and what do we not understand? Because that's very important, and it's very important to understand that in terms of policy. And then the third thing I want to talk about is, you're going to think that I'm funded by the pharmaceutical industry, and that's about catastrophes, terrible things that could happen. The pharmaceutical industry produces antidepressants, which some of you will want to take after you hear me. But I want to talk about, since we're going to talk about climate catastrophes, I'm going to talk also about other catastrophes, and how do we think about them once we're also thinking about climate? I mean, do we just sort of separate them and look at them separately, or do we have to put them together? So that's the plan, okay? And I guess what we're going to do is that, we'll have a lot of time for questions at the end. But if I say something that you think is really confusing, raise your hand and we'll clarify it. Okay. So first of all, catastrophic outcomes. What is a catastrophic climate outcome? Let me begin with what is not a catastrophic outcome. A 2-degree increase in temperature by the end of the century, 2 degrees Celsius. Increase in global mean temperature by the end of the century is not a catastrophic outcome, in that it's very hard to see how that would lead to a major loss of GDP, gross domestic product, a major loss of life, a major loss of things that we would worry about. It's not that it wouldn't have any impact, it would. And in fact, the impact would be positive for some countries. Canada would do well. Russia would do well. The United States almost breaks even. But there are a lot of developing countries that don't do well. The net effect is negative. The issue isn't catastrophic. So what is a catastrophic outcome? Let's think about this in terms of a loss of GDP. Now, once I talk about GDP, people get upset. Oh, as you economists, all you care about is GDP, and that's not what the world's about. Not just GDP. Many things that go into human welfare. So when I say GDP, I'm going to use that term broadly. So it's going to include the GDP that we measure, right? And it's going to include monetized things that can go into GDP, such as health, mortality risk, things like that. So, for example, if climate change leads to major health issues, leads to greater morbidity, all right, or a higher rate of mortality, we would try to monetize that, figure out what that means in terms of equivalent GDP loss. There are ways we can do that, and in fact, economists do that all the time, because when we look at safety regulations, health and safety regulations, and we want to do cost-benefit analysis, we have to translate lives that would be saved into dollars. Otherwise, how do you do it? So, for example, when in the United States, when the Environmental Protection Agency decides to require some kind of regulation, or when they decided to require automobiles to have airbags, airbags add about $500 to the cost of a typical car. How do you know whether that's worthwhile? Well, you figure out, you estimate how many lives will that save. You have to translate that into dollars. And there are various ways of doing that we can get into later, but it can be done. There are ways to do that. Again, a lot of people don't like that. They hear economists doing this and they think, something's wrong with us. but we do it. And that's how we think about policy. Look, what can I say? That's my job. That's what we do. And that's how we look at policies, like airbags, like a whole variety of safety regulations and health regulations and so on. So when I talk about GDP, I'm going to use that word, but I mean it broadly, and very broadly, to include other possible effects of climate. Now, there's one special effect that's a little difficult, and I have to get to that more at the end, and that's the effect is death, mortality. This is very complex about how we think about death. And do we view mortality here in the UK or in the US the same way we do in Bangladesh? And we're going to have to talk about that because that's something that comes up when we look at climate catastrophes. Now, if we think about a catastrophe in GDP terms, well, let's look at big bad events that happened in the past. So one big bad event was the Great Depression. And the Great Depression caused a drop in GDP, sustained for about 8 years, even more, of about 25%. 25% drop in GDP. And it was a terrible event, not only in the United States, but around the world, right? It was not distributed evenly. The unemployment rate at that time in the United States went to over 25%, as well as the drop in GDP. We think of that as a catastrophe. We think of World War I as a catastrophe. We think of World War II as a catastrophe. I put it in GDP terms just to give you, using that measure. In Japan, at the end of World War II, the GDP was at least 50%, maybe 60 or 70% lower than it was at the beginning of the war. So Japan lost about 60% of its output, of its economic welfare, so to speak, right? Leaving aside all of the death that occurred. So I'm going to take a 20% drop in GDP or greater to be a catastrophic outcome. And I have to tell you that none of the studies that I've seen using models, integrated assessment models and stuff like that, none of them get to a 20% drop in GDP unless you look at very large temperature increases, 6, 7, 8 degrees. It's very difficult to get to that kind of loss. And the reason for that has to do with adaptation, because climate change happens slowly and we adapt. The issue is to what extent can we adapt, right? But we want to know what is the chance of a 20% or greater drop in GDP, equivalent. What is the chance of that? That's what matters. Now, why does it matter? Why does only that matter? What's wrong with a 5% drop in GDP? That's pretty big. Why doesn't that matter a whole lot in terms of getting us to do something about climate? So one reason is that it has to do with discounting. Climate change happens again slowly, and the major effects of climate change are unlikely to occur for at least 50 years. And when I say major effects, some of you are going to say, well, there's already things happening. I think that today is a record, isn't it, in London, in terms of hot weather? So you're going to say there's already things happening. Yes, but they're not terrible things. In other words, what's been happening so far is nothing in terms of a loss of GDP, a significant loss of welfare. So when we look at things that might happen, a 2-degree increase in temperature, let's say, 3 degrees, we're looking at the end of the century, the year 2100. That's very far away. And that means that the value today of the benefits that we get by spending money to reduce emissions, for that we have to pay immediately. You see, if we're going to reduce emissions, we have to do things right away and spend money right away, raise our costs right away. We're going to incur those costs now, but the benefits are not going to happen in terms of avoided damages. Won't happen for many years. When you discount that to the present, to put it in present value terms, well, you don't get much. And the discounting means that a 5% drop in GDP at the end of the century just doesn't matter when it comes to spending money today. It just isn't going to do much for you. It's not going to justify much, all right? You need to have something big and bad happen. You need to have a catastrophic outcome. And that means that we need to think about, what are the chances of a catastrophic outcome? What are the chances of a event, climate event, that would be so bad that it would cause GDP at the end of the century to be 20, 30, 40% below what it would be otherwise, all right? That's what we need to get at. And how can we get at that? And you may say, well, gee, we can use models to get at that. And I'm going to tell you and explain to you soon that the models, there are a lot of models around. I don't know if you're aware of this, but there are these things that are called integrated assessment models. How many of you have heard of those? Everybody. And these great big models, that's an industry, by the way. It's a growth industry. You should invest in their stocks if they're trading on the stock market. They're doing very well. So that's a growth industry. There are many of these models. They're huge, huge models. Everybody's building them. And I'll tell you soon why they're not very useful. In fact, they're worse than that, but I'll explain that soon. But they're not going to tell you, those models can't tell you anything about catastrophic outcomes. I mean, you can assume things, and that's what sometimes is done in the models. You can assume that various paths will occur, various things will happen, but the models themselves don't really explain anything. So there's a real issue of how do we figure out what the chances are of a really bad outcome. Because if there isn't going to be a really bad outcome, catastrophic outcome, if that's not going to happen, we can all go home. We don't need to worry about electric cars and turning off the lights and any of that stuff. We don't have to worry about that. But we have to worry about that only if there's a reasonable chance, even a small chance, 5% chance of a really bad outcome. Now, how do we get that? How do we figure that out? And why can't we use models? So now I want to come to what we know and don't know about climate change. Then you'll see whether there are issues about the models. So here's what we know about climate change. We know that when you burn carbon, it creates carbon dioxide. And that goes into the atmosphere. And it collects in the atmosphere. And as time goes on, there'll be more and more of it in the atmosphere because it stays there for a long time. It dissipates very, very slowly. So as we burn more and more carbon, we're going to create more and more atmospheric carbon dioxide. And atmospheric carbon dioxide affects temperature. Now what we can do pretty well is based on, GDP, based on economic activity, we can project how much carbon dioxide will emit, we meaning the whole world, will emit if we don't do anything to stop it. Or we can project what will happen if we do certain things, like have a carbon tax, for example. All right, and we can do that pretty reasonably, and not accurately, not exactly, but to some degree, we can do it reasonably well. We can also project reasonably well what the concentration will be in the atmosphere under different scenarios of emissions. We can do that pretty well. Now we want to go from that to temperature. And we want to ask, if we increase, let's say there's a doubling of the atmospheric CO2 concentration. We want to know what that will do to temperature. That's called climate sensitivity. That's the formal term. Climate sensitivity means what will the change in global mean temperature be after a doubling of the atmospheric CO2 concentration after we allow things to get into equilibrium, which could take 40 or 50 years, right? We don't know climate sensitivity. Yeah, question?
I don't understand what you mean by equilibrium.
Okay, so let's do an experiment. We're going to burn a lot of carbon, we're going to double the amount in the atmosphere. And now we're going to do it all of a sudden, really push a lot of carbon in the atmosphere. We're going to double the concentration today. What we need to do before we ask, well, when will the increase in temperature occur, a whole bunch of physical processes have to take place. Until those physical processes are done, which can take 40 or 50 years, the temperature gradually increases. So we want to allow those physical processes to operate. in the end, before we can really see, okay, this is how much the temperature will go up. That's all I meant. So, we know the temperature will go up. One more thing, I'm sorry. When I say temperature will go up, temperature, I mean to include other things. So I'm going to use temperature as a word that includes other possible effects of climate change, such as weather variability, more higher variance of temperature, more storms, more variability, okay, maybe higher sea levels, all of those things. I'm going to wrap it up into temperature, just to use one word and not have to, every time I say it, say all these other things. So I'll use temperature. All right, why don't we know climate sensitivity? This is really important. Why don't we know it? We understand a lot about the physics and the atmospheric chemistry. The problem is that there are feedback loops. There are 4 or 5 very important feedback loops. And we don't know the parameters of those feedback loops. We don't know how strong they are. We simply don't know. In fact, it's even gotten worse. Climate scientists have learned a lot in the last 20 years. And just in the last 10 years, what they've learned is that we know less than we thought about those parameters. That our uncertainty about the feedback loops is greater than we thought 5 or 10 years ago. So we just don't know the feedback loops. We can make assumptions, we can try something, we can say, what if it's this, what if it's that, but we don't really know. So that's a problem. We don't really know what will happen to the temperature if we increase the atmospheric CO2 concentration by some certain amount. We just don't know. Now, on the other hand, at least we can talk about it intelligently. We can discuss the physics of it, geophysics. We can discuss what's going on. We can talk about the feedback loops. We can argue about it. We can have a sensible, intelligent conversation. We could disagree. Some people might argue that the feedback loops or the feedback parameters are this. Somebody says they're that. We can argue about that. What's the evidence? We can have an intelligent conversation. Now we get to the next step. Let's suppose we knew what the increase in temperature will be. Now we want to know, so what? What is that going to do to GDP? Once again, I'm using GDP to mean a variety of things. What's that going to do to GDP? We know nothing about that. I mean, zilch, zip, nada, nothing. Any other one you want to try and
Nichts.
Yes, okay. No, am I clear now? Is it clear? Have I made myself clear? We don't know a thing about this. And the reason we don't know a thing about this is that there's no theory, there's no economic theory, there's no physical theory, there's no any theory. There's no theory and there's no data. We haven't had a 4-degree, in terms of a modern economy. If you go back several 100,000 years, there have been big temperature changes. But we didn't have, London didn't look like this 100,000 years ago. All right, we didn't have an economy back then. We've no experience with this.
So could you maybe just clarify a little bit? When you say temperature, you say you're wrapping a whole bunch of things into that on temperature.
Yeah.
But then you talk about 2 degrees and 4
Yeah.
degrees. And I don't understand. So those things don't come in degrees.
Sure, let me do this. Let me for the moment focus on temperature. And then when we talk about damages, the impact of higher temperature, I'm going to include possible things like sea level increases or variability. So I'll keep it to temperature because we understand what that is. So even if we knew, even if somebody could tell us that under business as usual, which means without any new policies to reduce emissions, that the temperature will go up by 3 degrees Celsius at the end of the century, we don't know what to make of that. What is that going to do? How bad is that? What's it going to do to GDP, to consumption, and so on? And again, there's no data, there's no theory. And furthermore, there's this problem called adaptation. So a good example of adaptation is what happened in the United States when people decided to go west. So they started out, as you know, they came from here, and they came to the East Coast. And I live on the East Coast, And if I go out in my backyard and I want to plant something, and I dig in the ground, what do I find? Rocks. So it's very hard to grow stuff on the east. Okay? So they went west. And when they went west, and they came to what is now Iowa and Kansas and Nebraska, right? You dig and it's beautiful, rich soil, no rocks. It's just fantastic. There's only one problem: the temperature. On the East Coast, you have the ocean that moderates temperatures. In the middle of the country, where you want to grow all the wheat and the corn and the soybeans, it gets much, much hotter in the summer and much, much colder in the winter. And the wheat and corn and so on that they were growing on the East Coast wouldn't grow in the middle of the country. And that's how we developed things called like hybrid corn. We developed hybrids. We experimented. We developed new strains of wheat, new strains of corn, and so on that would grow in those kinds of conditions. Well, that's probably what would happen if temperature changed globally. There would be adaptation. You know, there are people who live now, and I have friends who live right now on Cape Cod on a bluff overlooking the ocean. It is beautiful. Okay, they're way up on this bluff. They overlook the ocean in Cape Cod, right? And what's under their house is eroding. And in another 10, 20 years, the whole house is going to go in the ocean. It's terrible. It's too bad. Maybe they shouldn't have built that house over there. So even without climate change, there are houses in places where you really shouldn't have houses unless you're happy to have the house last for only 10 or 20 years. And with climate change, maybe there will be faster, erosion and more, increased sea levels. Maybe more of those houses will go into water. But again, you move. You don't build houses in those locations. You adapt. So when you go to the beach, you sit. It's low tide. You put your chair down and you sit. You read a book. You relax. And now the tide comes in. What do? You just sit there as the water goes over your head. Maybe, I don't know. I don't. I move. You move. You adapt. And we don't know. This is the problem. We don't know to what extent we can adapt. We know there will be some adaptation, but we don't know how much. So that brings us to question?
Just ask, small island states will probably be in a situation where they will find it very hard to adapt within the geographical footprint.
The Seychelles and some of the small island countries, that's right. That's right. And so there's an issue of what happened. What do you do? And there may have to be transfers to deal with those people. So
is that not catastrophic?
Well, let me put it this way. So I hate to talk like this, but Hurricane Katrina killed, about 400 or 500 people and totally devastated a huge area of Louisiana around New Orleans. It had an unmeasurable impact on U.S. GDP. Unmeasurable. It was zero, practically.
The impact on Tuvalu, would you hazard a quick guess on the GDP impact?
Hang on. The GDP of that area of New Orleans was definitely impacted. So when you talk about catastrophe, we have to be clear about what we mean. There's no question. All the time, there was a tsunami. You remember that? That was a catastrophe that killed hundreds of thousands of people. The issue is, these are localized events, and I'm going to talk later about catastrophes that are more global. There are always events where localized regions get devastated, but we're able to help and do things. So we can do things with New Orleans, and we may have to do things with those islands, with those people, right? That's a fact. That's just how it is. In other words, you're going to have to ask, what is necessary. That's part of adaptation. Is some people might have to literally move from those islands. Let me go on. So we don't know what would happen. We don't know what the impact would be. All right? Now, let me get to the models. What the models do, and this is why I find them problematic. Here's what the models do. The models start out by saying, okay, you have economic activity, it produces carbon dioxide, it goes in the atmosphere. Fine. It goes in the atmosphere, it collects, it increases the concentration of CO2. Fine. That increases the temperature. We don't know how much it increases the temperature. And the models and the modelers don't come straight about that. They make, we know what's going to happen. Then we get to the really bad part, what we call the damage function. What is a higher temperature going to do to GDP? And by the way, all of these studies measure impacts in terms of GDP. That's it. And that's totally made up out of thin air. What they do is they make up functions. So, so what they'll say is that there's a loss function. And the loss function looks like this. It's 1 over, let's say, 1 plus alpha 1 t plus alpha 2 t squared. This is in one of the famous models. And GDP is going to be this thing times what GDP would be if you didn't have a temperature increase. T is the increase in temperature above what it would be if we didn't have humans mucking around, right? And where did this come from? Nowhere. It was made up. That's all. I mean, I could have written cubed. I could have written to the 4th power. I could have written anything. But that's exactly how this thing came about. Totally made up. And where do the parameters come from? Totally made up. In every single model, this stuff is all made up. There's no theory, there's no data, there's no nothing. It's made up. And then what it does is you run the model on a big computer. That's impressive, right? On a computer. And you get answers. That's what these models do. And I don't mind, look, I think these are useful as pedagogical tools and playthings. What bothers me is when people use them and say, look, we're going to project what's going to happen using these models. And the reason it bothers me is because they're used as, they give a sense of legitimacy that's false. They give a sense of scientific accuracy. We really know what's going on, and we don't. And because they're run on computers, and nobody understands even what's in the models, because they're very complex, we're supposed to take that as something that makes them legitimate. And we're really just kidding ourselves. So, where does that leave us? We have these models, and look, probably some of you in this room build models, and I'm sorry, what can I say? This is my view. And I've expressed it many times that these models, I've used the words, not just useless, but can be worse than that because they convey this false sense of scientific legitimacy because they run on computers. All right, so we have a problem. We don't really know what's going to happen under various scenarios for emissions of CO2. And what we think, or what we do know, is that if middle of the road things happen, we're not going to be too worried. Because even if there are some regions, like an island country where people have to move, there are enough resources in the world to make that happen. What we worry about is something that would cause at a world level, a worldwide level, a GDP drop of say 20% or 40% or something like that. Really catastrophic. That's what we worry about. And then we get to the question, how are we going to figure that out? And here, we're a little bit stuck. All we can do, in my view, at this point, is we can ask people what they think. When I say people, I mean people who've studied this. I'm going to call them experts for the moment. I'll tell you more about what that means. Experts who've studied this. And we're going to say, look, what do you think are possible scenarios? What's the probability that under business as usual, we're going to have a 10% drop or greater drop in GDP? 5%, 10%, 20%, 50% drop in GDP. What are the probabilities? What do you think they are? And we can take that information and then ask one more question. What would it take to eliminate the worst cases, the 20% or greater? By how much do we have to reduce emissions? Okay, we ask that. We have to reduce emissions by 10%, reduce emissions growth by so much. What is it that we have to do? If you calculate the benefit of truncating the distribution, the probability distribution of outcomes, in other words, eliminating the worst outcomes, calculate the benefit in present value saved GDP terms, and divide that by the amount of emissions that would have to be reduced in total over some time horizon, that's a measure of a social cost of carbon. It's an average social cost of carbon. And that's a guide for policy, because that tells you effectively what you have to do. If the social cost of carbon comes out to be $100 per metric ton, it says that we need to have a carbon tax roughly $100 a metric ton. Now, what comes out of the models right now, they were used in the United States because under US law, you got to come up with a social cost of carbon in order to have regulations. So in the US, agencies, state and federal agencies need a social cost of carbon estimate in order to impose regulations. And so what they did is they took 3 of these integrated assessment models and they ran them and took averages. And they got numbers around $39 a metric ton, okay? Which is actually a pretty small number. If you think about it, what it means in terms of translated into a gasoline tax, it comes out to about a 40 cent a gallon. What is that? About 10 cents a liter, okay? About 7 British cents per liter. That's what it is. It's pretty small. But it's small because most of what's driving it are these middle of the road, most likely impacts. Not catastrophic impacts, because nobody knows about the catastrophic impacts. So in my view, the best we can do at this point, until the science gets better, is really try to see what are plausible numbers for probabilities of different kinds of impacts. Is 20% or greater drop in GDP, is a 5% probability plausible? 10% probability plausible? 15%? How do we get those numbers? And I don't see a way to do it without just asking people. So that's what I did. I created a survey, and I surveyed several thousand experts, and I'll explain how they were chosen in a moment. And I got about 1,000 responses, and I calculated numbers, and I'll tell you what the answers were. But before I do, I just want to tell you what I mean by experts. So, who's an expert? So what I did is the criterion I used, I wanted it to be inclusive and totally objective. I don't want to say, you're an expert, you're not, and so on. So what I did is I based it on highly cited publications related to climate change. And this included people who are economists working in climate scientists, obviously, who are working in climate, environmental scientists working in climate, and so on. And we looked for publications in the last decade, the last 10 years, and we looked only for publications that were the top 10% of citations. Now you might say, look, that means you got a lot of academics, and we all know that academics don't know anything. They're not experts, they don't know anything. They live in the ivory tower, right? So, well, then you'll have to do your own survey. And I did this not with the intent of coming up with final numbers, but I did it with the intent of showing how this might work. What are the results that I got? The results that I got were interesting in 2 respects. First of all, the average social cost of carbon that came out of this study was very, very high, over $200, sometimes as high as $300. Very high numbers, really high numbers. Secondly,
Sorry, why is that high?
Well, because, let's put it this way, in terms of all of the policy discussions that have been going on, the IPCC, the US, the Interagency Working Group, all of the discussions have talked about a social cost of carbon in the range of $50 or so, less than, equal, a little more, around 50.
$50 for how long?
Well, the $50 is the current social cost of carbon. In other words, what it says is that you want to have a carbon tax today of $50 per metric ton of CO2 emitted. That's what the numbers, that's what they talk about.
So it's per metric ton.
Oh yes, it's per metric ton, not of carbon, but carbon dioxide.
Right.
That's how we measure it. So those are the kinds of numbers that everybody talks about. And again, in the United States today, the number that's used by regulatory agencies is $39. Okay? And that's the number. And we're getting numbers that are much, much higher. Second, the dispersion is huge. So if you take individual answers and look at these people individually, the numbers range from very low social cost of carbon to as high as $600-700. Big dispersion, lots of disagreement. Next, economists end up, you break up the sample into economists versus people who say their primary expertise is climate science. The economists end up with lower numbers than the climate scientists. The economists give you numbers like 107, it's still very, very high. $170, climate scientists maybe $300. Next, there's no difference, I thought there would be, no difference between the United States and Europe. Same, almost identical numbers in both locations. We're able to locate where these people are. The results are all anonymous, but we know the location of where the person took the survey. Okay? So that's the first thing we found. We looked at this and we said, well, what do you make of this? What do you do with this? Well, maybe you want to trim the sample. Maybe you want to get rid of the outliers. In other words, the people below 10% and above 90%. What I mean by that is people whose answers were outside the 10 to 90% interval. Maybe we do that. And that reduces the number somewhat, gets it down to about $200. Then you might ask the following. We added a question. We said, how confident are you in your answers on a scale of 1 to 5, where 5 is very confident, 1 is not confident at all? What if we only take the people who put 3 or higher as their confidence and trim the sample? If we do that, we get a number around $80. Okay? So you can get the number down if you're willing to say, wait a minute, we're only going to look at people who express more confidence, and we're going to trim the sample. If you say greater confidence but don't trim the sample, you get a number of around $120. Now, what's the right way to interpret this, and what's the right number? I've just finished writing the paper, and my answer is, I don't know. I mean, I leave it for people to, you decide. If you want to be democratic and include everybody, it's a big number. If you want to include only people who feel confident about their answers, it's a smaller number. If you want to include, trim the sample in various ways, you can get the number down. Whatever you do, the number is much bigger than anything that's being used today in climate negotiations, in policy in the United States, and so on. Because even if you get that number down to $80 per metric ton, that's double what's being used today as kind of the base case standard number. It's a big number, all right? And I didn't do this, again, with the idea of coming up with the right number for the government to use. I did this with the idea of showing how you could do it and how it's an alternative to using models. And the reason I prefer it to models, you might say, look, these experts, don't they have models? Don't they use models of their own? Some may, some don't. What I like about it is that it's clean and it's transparent. All I know is that you say the probability is whatever it is. You give me your probabilities, and I take what you said and I use it. I don't have a complicated model that I'm running that nobody understands, that I made up out of thin air. So I find it simple and transparent, and that's why I prefer it. Now, question?
Sorry, but aren't they, when you're asking them their numbers, aren't their numbers coming from their made-up model?
Well, I can't hear you. What?
Sorry. When you ask them and they give you numbers, aren't their numbers coming from their made-up models?
Some might be. I don't think, we ended up with 1,000 responses. I don't think they all came from models. But some might have. Some might have and some didn't. It was whatever it came from, it came from.
How many questions are you asking them?
Only about 6.
Right.
That's it. So it's a fairly short questionnaire. It takes about 10 minutes to answer. Now, let me tell you the reason for the wide variation. There's wide variation in people's beliefs about the chance of a catastrophic outcome. there are quite a few people who think that a catastrophic outcome has a probability of, 18%, 20%, 25%. That's a big number, big probability for an outcome of a 20% drop in GDP or greater. So let me move to the next step now, which is, let's assume that we have a problem with climate. We have a problem with climate because we can have a catastrophe. Maybe not, but there's a possibility. And it's a reasonable possibility. It's not, way out in the far reaches, highly uncertain, highly unlikely. It's something that could happen, maybe 10% probability, 20%, something that we really have to worry about, a catastrophe. It would happen by the end of the century. Once we're in the world of catastrophes, then I think it's time to close our eyes and dream. And I ask you, what's your list of catastrophes? What is it you worry about? I ask you the following question. What could happen in the next 50 years that would have a devastating impact on humanity in the world? Worse or equal to a 20% drop in GDP. Worse or equal to the Great Depression. What are the things that you would worry about? What are the things, think about this a little bit. I'm going to give you a minute to think. What is it you worry about? What could happen that would be absolutely terrible?
Immunity to antibiotics.
Hang on a second. How many of you can come up with at least 2 or 3 things? Let's start with that. Some people have no imagination. I don't know. The movie theater's closed tomorrow. That would be terrible. All right, let's hear some ideas. Let's get some hands. So hands.
A huge influx.
I have to agree, but I shouldn't. I'm not supposed to do that. Yeah.
So
I'm sorry, about your hand.
the extinction of certain animals.
Extinction of certain animals, okay. And
I was going to say Yosemite National Park erupts.
loud.
Yosemite National Park erupts, the volcano there.
Yeah, and how many of you are aware of this? There was a very nice article in National Geographic. This is what we call a mega volcano. And I don't remember, I looked at the study, I don't remember what they viewed as the likelihood of the next 100 years of it happening. It's pretty significant.
They've said it's overdue based on its cycle.
That is quite likely. And this would be something that would literally destroy a good part of the United States. Now you may say that's not a catastrophe, that's fine. Anyway, that's an example. And something related to that is what we call a mega earthquake. And a mega earthquake is unlike any earthquake we've experienced. But people work out the probabilities of these things. It would literally split off half of the United States and destroy it, the western half. That's another catastrophe. More. Let's hear more
A
ideas.
methane release
A
from
methane.
these lakes in Russia.
From Siberia.
From Siberia.
Oh, that would lead to.
Yeah, it would swamp all this carbon.
Yeah. And let me put that under. That's climate change that has nothing to do with human activity. Good point. So that would be. We see it in the form of a climate catastrophe, but it would not be because of human activity. And turning off the lights won't help.
It would be triggered by.
It's triggered by human activity.
Oh, I see. It could be triggered by. Okay. Then let's put that under climate. And let's look at non-climate. Go ahead.
A zoonosis that has a long onset and is highly lethal.
I couldn't hear.
A zoonosis that has long onset and is highly lethal. A zoonosis is a pandemic that
Oh, a pandemic.
and it goes from animal to
Got it.
human.
Yes, zoonosis, yes. A pandemic that comes from animals to humans. That is, I'll tell you something. If I go walk into the Grantham Institute, is it here or there or whatever, everybody's talking about climate. If I go to another area where you have virologists and epidemiologists, they will tell me that, what are you worried about climate for? Half the population is going to be dead by then. Because we're going to have a pandemic that's we've never experienced. It's going to be zoonosis. It's going to be transmitted. It's going to be mutation from animal to human. And remember, the Spanish flu of 1918 killed 5% of Europe and the United States. 5% of the population. It also killed a significant percentage of other countries. We just don't know the numbers. But we know that for Europe and the United States, the Spanish flu killed 5% of the population. That's a hell of a lot of people. And now think about something that's much worse than the Spanish flu. That would be a very serious catastrophe, and for many people view it as much more likely than a climate catastrophe, and something that would happen sooner than a climate catastrophe. Next 20 years. Yes?
We have enough nuclear weapons to wipe out the human population several times over. We're counting on sanity. Don't press the button.
Right.
Donald Trump.
That gets really important. So the next catastrophe would be, let me express it this way, nuclear war. All right, and you can have your own dreams, your own scenarios, your own ideas. How would it start? Would it start with, I don't know, Pakistan and India? Would it start some other way? But nuclear war could, especially if it's spread, could be absolutely devastating to humanity. And then related to nuclear war, which my friends at the Kennedy School will talk about this all the time, they say, what are you worried about climate change? What are you worried about pandemics? We're going to have a nuclear terrorist attack, almost for certain in the next 10 years or 20 years. So Graham Allison used to be the dean of the Kennedy School of Government at Harvard. He's a professor there. He has a very nice book. For those of you who get too sleepy and want to stay up all night, it's a very nice book. It's called On Nuclear Terrorism. And his point is very simple, and he explains very, very clearly why nuclear terrorism is so easy to happen. And the reason is that all you need is the material. All you need is enriched uranium. The hard thing is making enriched uranium. See, that's what Iran's been trying to do, spin centrifuges. That's hard to do. Once you've got the enriched uranium, making a bomb is really easy. A college physics student can do it easily, all right? And the bomb would be something that would fit in a suitcase and would have the power of the Hiroshima bomb. So imagine 2 or 3 of those being set off in major cities in the world. And what that would do, it's not just how many people it would kill right away, it's what it would do to the way we live. It would be an unbelievable catastrophe. And, let me just tell you, that's something that we worry about as probably more likely, maybe more likely, and certainly sooner than climate. You were going to say
I
something.
just think that falls into your category of localized disaster. It's not on the scale with global thermonuclear war or a biological warfare that releases an engineered virus that kills billions of people.
Right.
It's killing a few million people.
Right. So let me explain why it's global. So the point is, let me just repeat your point. And many people say that. They'll say, okay, so there are several nuclear bombs go off, New York, London, Chicago, whatever. And, we're going to, several million people die, 3 million people, 1 million in each city, and we have to evacuate the cities, and all that's bad news. But hey, there are other places to live, right? It's localized. You have to go beyond the immediate effect and think about what it will do to the way we live. Right now, when you go to the airport at Heathrow, you have to get rid of the toothpaste and get rid of the bottled water. And I guess you don't have to take off your shoes here. We do in the United States. And you have to, all this stuff. Just think about what it will do, how we will live after that kind of nuclear terrorism happens. And remember, if it happens once, it's going to happen again. So think about what that would do to commerce and life as we know it. It would be devastating. But again, people come up with different numbers as for the impact.
What if we wanted a different sort of life anyway?
If we want a different life?
Well, we could easily stop driving too many cars, eating beef. And some of the things you mentioned are viruses, not just related to our emissions of carbon dioxide and heating up, but they're also related to how fast we run around the world, how far, and the sort of mechanisms we do.
Yeah.
It is our lifestyle that's creating a lot of these, perhaps not the Canary Islands, in fact, half of that falls off from the tsunami drowns New York, or the Yellowstone National Park. But many of these others are related to the way we live.
But there's no question that one of the reasons why a pandemic today would be worse than 1918, because in 1918, you know, we didn't fly all over the place. You didn't have everybody flying and traveling and all that stuff. You didn't have, you barely had cars in
No, I can't
1918. What?
Sort of go back home.
I'm gonna go back home, right. I'm gonna fly home.
Don't come here again.
Yeah. So, you know, sure, I mean, there's no question that our way of life makes this happen. But all I'm saying is that we live the way we do. We're not about to end, you know, air travel. We're not about to shut down air travel. And we're not about to get rid of cars, and we're not about, some of you may want to stop eating beef and not fly and whatever. That's fine. But we have a way of life, and the question is, what are the chances of a catastrophe? That's what we want to know. So we've got several already. You know, we've got mega earthquakes, mega volcanoes. We've got, and we could add to that mega tsunamis. But we've got to that, we have in addition things that could be far worse. We have a mega virus, a terrible pandemic that could spread around the world quickly and kill huge numbers of people. Nuclear warfare, nuclear terrorism. We didn't really talk about it, but bioterrorism. So biological agents that are released by terrorists. You can come up with terrible ideas. You want to add one, or? Well, I'm sorry, I thought you wanted to. So you know, yes, go ahead.
What about an academic catastrophe where that damage function in 50 years turns out to be exactly the one that we had needed, but we ignored it?
I mean, this is the right
It could have prepared us and it did, because we chose to ignore it because it might have been wrong.
Well, this particular damage function doesn't give you much damage. So if this is the damage function you want to use, it's going to give you a very small social cost of carbon. It's going to give you a $10 social cost of carbon. It's going to tell you not to do anything. Because if you put, well, let me just tell you that this is the damage function that's used in the Nordhaus model. And that gives you very low estimates of the social cost of carbon. You need a bigger damage. You need to make this a cube or to the fourth power or come up with something else. All right, look, so here's the issue. We face a variety of catastrophes. We as humanity, we face a variety of catastrophes. And now we come to the next question. Can we deal with them one by one? This is the climate department, we're going to deal with climate. Over there is the nuclear terrorism department, they're going to deal with that. Over there is the virology and epidemiology department, they're going to deal with pandemics. All right? And we're going to do this individually. And what we're going to do is come up, use cost-benefit analysis to figure out what to do in every case. And let's suppose we do that. And in every single case, we find out that what we should do is spend a lot of money to prevent that catastrophe. By the way, right now we're spending almost nothing on pandemics, less and less every year. Budgets for the World Health Organization, the Centers for Disease Control have been cut every year. We're spending almost nothing. We're spending almost very little on nuclear terrorism. Anyway, let's suppose we come up with estimates of what we should do. Can we then deal with these things individually? And the answer is no. And that's where my work on Scylla and Charybdis, the strange economics of Scylla and Charybdis, this work with Ian Martin here at LSE, where we have shown that you cannot look at these things independently. They're all interrelated. And the reason they're interrelated is because they all have major impacts on GDP and consumption. They're not marginal. You see, when economists do cost-benefit studies or finance cost-benefit, it's marginal. We assume that it's not going to affect the overall economy. But these things, by definition, affect the overall economy. And what that does is it creates an interdependence. And it may well be that even though treated individually, you would do certain things, you would do certain things to prevent climate change, maybe prevent bioterrorism, whatever. It turns out when you put them all together, you might only prevent 5 out of 7, or 4 out of 7, not all of them. And the 4 or 5 that you prevent are not necessarily the ones with the highest benefit-cost ratios, which is why we called our paper The Strange Economics of Scylla and Charybdis. So it turns out that when we get into this world of catastrophes, life gets really complex. Understanding what to do gets really complex. So let me stop here. You're going to hand out antidepressants? No?
I wish I had any.
All right. Well, so let's get some discussion and so on. Yeah. Right.
And if you don't, right, yeah.
in the green shirt.
I accept.
But loud, because this room is.
Yeah, I accept your critique of models, but I'm not convinced that you yourself are not also using a model of sorts. Maybe not a kind of widespread model, but certainly a model in economics. And the example I would give is, although you touched on nuclear catastrophe in a terrorist sense, you mentioned Japan a number of times, but you didn't mention any of the catastrophes of a nuclear kind which have afflicted Japan and could actually afflict other countries. And if we take nuclear rationality as an economic model, there is no economic rationality attached to it. The state is always underwriting nuclear energy and nuclear warfare. It's always been the case. There's never been any economic rational justification for nuclear sourcing. If you take it in the case of energy, nuclear energy has the highest cost overruns and the highest time overruns of any energy source. And yet,
No,
you mentioned...
you have to come to a question.
Yes,
because
but
you don't have
yet,
enough time,
yet
actually.
you mentioned the economic viability in terms of catastrophes, but it's not applied in this case.
Actually, look, nuclear power is disappearing. Germany's getting rid of all of its nuclear reactors. I don't know how many nuclear reactors there are in the UK, but the numbers, I thought are going down.
15.
How many?
There are 15 currently that are operational.
And how many
There
are
are
being?
proposed 4 to be built.
Okay. So, and will any of those 15 be eventually shut down?
They will all eventually decommission.
Okay. So anyway, if you look at nuclear power around the world, it's disappearing. We're basically shutting down, generally speaking, nuclear reactors. We're using less and less nuclear power. Now, I don't want to get into a debate about whether that's a good thing or a bad thing, but there's no question. One of the reasons we're getting away from nuclear power is that it's very expensive. It is economic. It's based on economics. It's very expensive. It's much more expensive than other fuels. That's why we're not building nuclear power plants, because it's too expensive. So I think the economics does apply. Yes. Yes, you.
Thank you. So, slightly circular, but hopefully it makes sense. GDP question. GDP is often services instead of food, right? So,
GDP.
if we're looking at suffering, let me see how to phrase this. If you look at suffering, you probably want to know about food. And as the population grows, we reach carrying capacity. So GDP being a judge of just monetary flow seems strange to me, but then again, I'm not an economist, so correct me that. But the question that I sort of want to ask is about food leading to war, leading to a multiplier on things like terrorism. Second World War came quickly after the First World War, that kind of concept.
Starting with food.
Say, for example. So with a smaller GDP impact, if it was based on food, you could have a larger suffering than other kinds of GDP impacts. War following from food potentially, and those catastrophes. Have you been thinking about the multiplier, the ways in which they're related, not just because of the trade-off with which you study, but how one impacts the next?
So so there are a couple of things. First of all, I mean, food is part of GDP. GDP is the value of all the stuff that think of the economy as a huge pipe.
What I mean
stuff
is,
comes out.
At a guess, I don't know, but it would seem that global GDP might be dominated by like manicures in the US.
Dominated by
Manicures in the US more than it should be, you know?
what in the US?
Manicures.
Manicures.
Whatever,
Oh.
you know what I'm saying? Like the monetary value we put into things that aren't essential for survival
Yeah.
might be skewing GDP.
Well, there's no question that, I mean, I hate to say it, most of what you're going to do in the next week is not necessary for survival. And I'm not going to talk about you personally, but for most people in this room, when you go shopping, think about it. How much of what you buy is necessary for your survival? Even in the food department, probably not much. So there's no question that lots of GDP is, not necessarily for survival. It is what it is. But you raised another point, and that is, couldn't a drop in GDP have further effects in terms of leading to war? Well, there's no question that part of what led to National Socialism in Germany, the Nazis, was the economic situation in Germany and elsewhere in the world. There's no question that there could be those multiplier effects. So sure, that's an issue. That's a problem.
Wasn't that reparations rather than...
Well, let me, hang on, so...
Are you like...
Let me leave that right.
Is that at all accounted for? I mean, that seems like a risk of... What are these catastrophes
Okay, look, so I'm doing this in a very simple-minded way. So look, I don't know what's going to cause. A couple of people raised the prospect of nuclear war. No question, that would be a terrible catastrophe. What we didn't discuss is what are the factors that would lead or might lead to nuclear war. Many things. I mean, this is not my field, so I can't tell you, but there are many things that could make nuclear war more likely or less likely. You know, are we going to have disarmament? Are we going to have nuclear proliferation? There are many things we can imagine that make it more or less likely. All I'm doing at this point is saying, look, these are things we need to worry about and maybe do something about. Not just climate, but these other things. Yeah.
I'd like you to explain more what you were saying about these being multiple possible catastrophes, but you would only attend to a few of them and maybe not the ones with the best cost-benefit analysis. Instead of fielding questions, I'm kind of left confused why that is.
So this is, I'm going to try to tell you why it is, and it's very hard to explain because our paper is, I mean, we're surprised, but we know it's right. So what happens is there's two parts. The first part is why do you not do everything? And the way to think about that is suppose there are 10 things you can do, 10 possible catastrophes you can worry about. And each one could reduce, you know, each one to get rid of it, to prevent it, would take 10% of GDP. You'd have to give up 10% of GDP. Well, if you got rid of all 10, you're going to have 0 GDP, then we all die. So you're not going to get rid of all 10. See, that's the fact that if there were only one, then you may say, okay, it costs 10% of GDP to get rid of it, but we'd save the possibility of losing 20%. That makes sense. But if there are 10 of them, and they add up to too much, then what happens is we say, no, wait, this is no good. We're not going to do all of them. That's the basic idea of not doing everything. Because now you're looking at the overall ability of a nation or set of nations to deal with things. The fact that you don't go in the order sequentially, which has the highest benefit cost ratio, that's a little more complex. Yes?
Thank you. Discount rate. When you're working out your social cost per capita of the survey, I guess you weren't asking people what discount rate you think, you were just working that out yourself. So what discount rate did you use, and how did you justify it?
So I did ask people about their discount rate. I did ask them, where's Ben did a survey with a couple of co-authors on the discount rate. They got, I think you got a number, where are your co-authors? Oh, look at this, okay. So these are the discount rate survey experts. And they got a number, I think it was around 2-3%, am I right?
Yeah, well, median of 2%, and well, depending on how you look at it, average of around 2.
Okay, so they got that number. I got a number, these people that answered, you know, around, I think it was 2.8, not that different from what they got. And so I used their numbers. By the way, not everybody agreed, so sometimes I used whatever they told me, and then sometimes I said, look, I'm just going to use the average number, 2.8 for everybody, to calculate the social cost of carbon. So that's how I did it. I let people tell me what they think it should be. So yes, in the yellow shirt.
Yes, also about the survey.
But loud.
Sorry, so it's also about the survey. So if you go with your proposal to have a different sort of assessment, not based on models, something close to survey, so we have to ask some question about the subjective probability of those experts, like in the direction you did with the confidence. So I had like a follow-up question on that. Did you have a way to control for the confidence based on the discipline of the experts, or maybe if they read your papers on models, it may reduce their confidence on their own probabilities?
Well, so here's what we know. We asked them what their major field of expertise is. Is it more economic, climate science, something else? We asked about their degree of confidence. I mean, that's as far as we went. So, you know.
But will you find a difference in the level of subjective confidence that is based on discipline? Let's say some field people, because of the kind of training and culture of the profession, will be more confident or not?
I'm sure we would. I mean, again, I didn't do this with the idea this is the final, this is it, you know, these are the numbers, now go and make it part of policy. I wanted to show how this could work. And other groups who actually probably know, other people know more than I do about surveys can do it right. Ben?
Yeah, related to that is sort of how you aggregate those opinions together. and it's related to confidence as well. I mean, so if I think about the economists we asked in our discounting survey, it's a similar kind of story, really. The way you treat your data is that each economist is kind of independent from the other, so they're bringing some new information to the question here. The reality, though, is that, if I think about myself when I was answering this question, it took me ages. It was actually more than 10 minutes, I can tell.
Oh my God, it took more than 10 minutes?
Yeah, I found it really difficult. But I was drawing upon other references, probably very similar references to other people. So the information I brought to this was probably the same as the next economist in the Grantham Institute or something like that. So I think in terms of the confidence of or the accuracy of the results you get, that's something which needs to be taken into account.
No, you're absolutely right. I mean, to kind of say what you just said in different words, I mean, people think alike, and they all sort of tend to reinforce each other. We all hear the same news, and we all hear the same stories. And I want to say a word about that in a moment. But you're absolutely right. So what your answers maybe were influenced by your colleagues at Grantham. Yeah. I don't know how many other people at Grantham took the survey, but but no question, you probably influenced each other, and that's right. That's an issue. These are things that people who do survey, you know this, the people who do surveys worry about this. How do you filter those effects out? What do you do? So, I didn't worry about it too much, you're right. But I want to mention one thing that just brought up, and that's about what you hear in the news. So there's a lot of news about climate. It's all the time, at least in the US, I think it is here too. You see it in the news all the time. All the time there's discussions about climate. You rarely see in the news discussions about pandemics. At least I haven't seen. Occasionally you'll see something. But you don't see that intense discussion in the news about pandemics or about nuclear terrorism, all right? Unless something happens. Now we worry that North Korea is developing a missile that could deliver a bomb to the west coast of the US. Aside from that, you don't see a whole lot about nuclear terrorism. And that influences what we worry about, and maybe incorrectly. Maybe we worry too much about catastrophe A because it's in the news all the time, not enough about B and C because they're not in the news. Yes, in the back.
Hello.
Yeah, thank you for the. Sorry.
Can we see, or are you considering?
A little louder.
Are you considering genetically modified foods as a one possible component of pandemics?
Okay.
Because it's a huge market and industry. I'm sure it's much more broader in the US if you contrast to other regions of the world. Are you considering this as a possible
Okay, so the
threat?
question is, are genetically modified foods,
Yeah.
first of all, could they be a source of a pandemic, or could they in themselves be a catastrophe? Something could happen. So I've never thought about them as being a source of a pandemic, and nobody I've spoken to has suggested that, but it's not my area of expertise, all right? Whether or not, genetically modified foods, there could be some problem where certain organisms escape and proliferate. I don't know. I haven't thought of that. Maybe it is. Maybe that's a possible source of catastrophe. Yes. To that?
What would be your overall recommendations for policymakers working on civil contingencies, for example, or catastrophe planning?
Well, I've actually gotten it's a part of Homeland Security in the United States that deals with this stuff, interested in this. So, try to get them excited about it. They're showing a lot of interest. Look, I think there are things we need to worry about that we don't. There's a very nice book that was written at least a decade ago by Richard Posner, a judge in Chicago, and it's called Catastrophe. And he talks about all kinds of things, asteroids and all kinds of things that happen. And his major point is that we don't worry about this. We don't do anything. We don't do much. We do worry about climate, but beyond climate, we don't do much. And we should. Now, he doesn't say how much we should do and what we should do. My own view is that there's certain things that we ought to be doing much, much more. Pandemics is one of them. We're doing very little right now in terms of developing the infrastructure, developing the technologies and the infrastructure to respond rapidly to a quick-moving pandemic that goes around the world. We're not doing anything. And let me tell you something else about nuclear terrorism. It's one thing, and then, you know, if you wanted to bring a nuclear weapon into the United States, you put it in a suitcase, you line the suitcase with lead, and you bring it on a ship that goes into the West Coast. None of that stuff is checked. Nothing's checked. Nobody will see anything. You just bring it right. If you want to bring, you know that we're, I'm really going to depress you, but you know what the airlines worry about, what keeps airline executives up at night? They're worried about shoulder-fired missiles. Because when Libya fell, when Gaddafi fell, he had 20,000 SAM-7 missiles that went missing. Did good guys take them? Bad guys take them? Who knows where they are? We don't know. We know that there are 2,000 US-made Stinger missiles, also shoulder-fired, that were lost in Afghanistan. We don't know who has them. All right? There are all these shoulder-fired missiles that are missing. Just imagine, you wake up in the morning and this is similar to 9/11. You see planes have been shot down from 3 major airports. What would that do to air travel? What would happen? Those can be brought into the United States and the West Coast. They fit in a suitcase. They're this big. We don't check anything that goes. Why don't we check it? Because it costs money. Because if you want to check every container that comes into the West Coast, it's going to cost lots of money. But we don't do it. But we don't do much about these other things right now.
How do you, just one follow on, how do you know though that if you're backing, say, pandemics and nuclear terrorism as the 2 out of the list of 10 things,
Have I got the right
how do
one?
you know you've got the right one?
I don't. I mean, I don't know. I don't. Go ahead.
Yes, my question is at the beginning, because you started saying that the model will bring to the wrong direction. And the reason what I don't understand is my question. If you don't have good data at the beginning, this means if there's not a kind of world, let's say global data collection where then you can start modeling, there's no way to go ahead. So this means the main focus is the knowledge, is the data, before you start with anything. And then they say if you centralize everything and you can connect with each other, most of this problem that you mentioned, catastrophe, earthquake, etc., you can, I don't say predict, but at least there's some indicator that something will happen. So what is your reaction to this?
Yeah, the problem, of course, if you could build a model and put things
this
together.
is what they're doing now, digitalization.
But hang on, but we can't when it comes to climate. We just can't. And you know what else? We really can't do it when it comes to nuclear terrorism. We don't know how to build these models. We can make believe. My concern about climate models is they're make believe. And they're made up to look scientific, but we don't really know what's inside them.
If you think you have hundreds of satellites going through the world,
okay,
there's a collecting data. The problem is they are not interconnected.
Okay. So maybe we need to interconnect the satellite information. I don't know. But look, let me just give you one more example. During the Cold War, the biggest catastrophe that we worried about was a thermonuclear war between the United States and the Soviet Union. And that would have, as you point out, that would have destroyed the planet. Only the cockroaches would survive. All right? That's what we worried about. So what did we do? We build models? No. What they did, the Defense Department and the RAND Corporation, which was contracted by the Defense Department, they looked at scenarios. They looked at what are possibilities and what are plausible probabilities. That's all they could do to come up with ideas, to come up with estimates, to come up with possible scenarios and what we might do to avert some of those scenarios. But that's all you could do in that situation. Well, maybe it's different today.
You have to hang on. There are around 2,000 people who want to ask a question.
Yeah, let me go ahead.
When it comes to the grim business of comparing catastrophes that you've gone into, I worry about the idea that we can do this by thinking about falls in or reductions in GDP, because that seems to miss out an important dimension, which is sort of the durability of the thing. So you can imagine a major pandemic, as has sometimes happened in the past, might run its course pretty quickly. Things are pretty shit for a few years, but then it's over. Life goes back to normal, things are okay. Or alternatively, you can imagine catastrophes which degrade and poison the environment for generations.
Right.
And both of those might involve the same fall in GDP, but they're of very considerably different order
I agree. That's right. That's absolutely correct. That's actually what we're working on right now. That my co-author here, LSC, is this whole issue of death versus destruction and how do you compare it and think about it. So that's our current work. I agree completely. Yes.
So the
But
federal,
louder.
yeah, the federal social cost of carbon and the models, they're based on the middling case, whereas the survey you've got is looking at the catastrophic case. So if you wanted a good estimate, wouldn't you want to add them together?
The model, what was used in the United States to come up with their $39 social cost of carbon, they took 3 of these integrated assessment models and ran them. They just ran them. And I don't think those models are worth anything. So I view that as a made-up number. Now, let me just say one more thing. Some people talk to me and they say, oh, you're a climate denier, and you don't care about climate change, and terrible, terrible. Look, my view is we ought to have a carbon tax. Plain and simple, just have a carbon tax. And I don't know what the right number is. I think it's more than $40. Is it 80? Is it 100? I think it's more than 40. If you want to start at 40 or 39, whatever they've got in the United States, start there. At least do something. Because right now we're not doing much of anything. Really, we're doing nothing. Okay. Let me, get back with the...
Yes.
But you have to shout.
Yeah, so you mentioned in the beginning of your presentation that you were going to say something about death. And your notion of GDP. I wonder whether you can say something about it.
Well, I can say a lot. I could spend another hour here on death. But, what we do is we know, here's what we know how to do. What we know how to do is we can tell you what the value is of a regulation that will reduce your chance of an auto fatality, reduce your chance of dying in a car accident by some very tiny amount. So already your chance is small. Let's say it's 1%, we're going to make it 0.5%. And we can figure out what the value of that is, and we can do it based on data. The data we look at is choices people make, for example, for different jobs that have different risks. We can do that sort of thing. What we can't do is ask you, what is it worth it to you to avoid certain death? That's a tough question. And that's actually what we're trying to look at now. We're trying to figure out how to extend the economics into this other area. But I'll be here all night if I... Yes.
Right. So you employ a discount rate, and I assume it's just temporal discounting. So what's your justification for claiming that the mere fact that a harm occurs 300 years in the future versus 200 years in the future makes it something we should be less concerned about?
Because again, what we care about is spending money today. So 300 years versus 200 years is a little tricky. I can get to that, but let's do 100 years from now versus right away. And the issue is that when we spend money today, there's an opportunity cost. The opportunity cost is that money could have been invested in productive resources. I don't mean bank accounts or bonds or stocks. I mean factories, things that create economic growth. And by not investing in that, we're giving that up. That's the opportunity cost of spending money today to prevent something 100 years from now. And the 100 years from now, the benefit, because of that opportunity cost, is related to time. Because over that 100 years, that investment grows and grows and grows. That's why you discount. That's always why we discount.
It's not the mere fact that it's farther in the future.
Well, if it wasn't in the future, we wouldn't discount. But the reason we discount things in the future is the opportunity cost. That's the issue.
Maybe we should take the last two or so.
Sure.
Just on that point, then, if you're looking at the work done by Stone prior to 2010, that kind of flipped that argument on its head, didn't it? Which said if you waited till later to spend on mitigation, for instance, it would cost you more compared to today. But you're comparing that to opportunity cost and the other way around. So, at least in the context of climate, isn't the economic notion that you should be spending today to avoid a higher cost to you later for mitigating?
So there's two sides to that. So the one argument that you've raised is by waiting, the cost will be worse in the future, you'll have to spend more in the future. The other side of it is that technology means that it will cost less in the future to reduce carbon emissions because we're getting better at knowing how to do that. So that's an argument for not doing much today.
But you might have reached a tipping point by which point it wouldn't matter, wouldn't it? if you didn't mitigate one now.
Yeah, but we don't, yeah. Yes, we might. If we reach a tipping point, we're going to tip. What can I say? Okay, go ahead.
So on the same topic, the problem with the discount rate you've accepted is that it basically relates off our great-grandchildren, right? Unless you make the assumption that we're going to have economic growth to compensate. So 3% economic growth per year. Are you not concerned that that might possibly produce some further problems, such as further breaches of the limits to growth, such as further carbon emissions, etc.? Do you think that it's prudent to gamble on a discount rate of 3% per year?
Well, first of all, I'm not claiming the discount rate should be 3%. And second of all, if
you allow that it should be 3%.
It might be, yeah. That's what the people told me. They think it should be 3%. Let me tell you something about discount rates. There's an economic theory of how you come up with a discount rate. And it turns out that in a world of certainty, 3% is probably a low rate, maybe 4%. But in a world of uncertainty, with possibilities of catastrophes, that means that the actual discount rate might be much lower, might be 0. All right? So what the discount rate should be is a complex issue. The problem with the models is that the modeler chooses the discount rate and can get any answer he or she wants by changing the discount rate. So imagine I've got a model, it's a great big machine here. Nobody understands what's going on, but I got a dial. And as I turn the dial from a very low discount rate, I get a huge social cost of carbon. Turn it over, high discount rate, I get a tiny social cost of carbon. And I, the modeler, choose that discount rate, and I get whatever social cost of carbon I want, and I claim it's great because a model generated it. That's what bothers me. All right. On this depressing note, let's stop.